Okay, we're recording. And let's go from current slide. And I don't have my, I had to remove this, of course, before I took it downstairs. My cord wasn't long enough, so forgot. Let's see if we can get it to work now. Yes. Okay. But before we get to that, I believe from what I heard somewhere, they have now opened midterm progress reports. So hopefully in all your classes, I'll have something for this, maybe. Okay. However, this one that I announced last week, problem solving day, tax problems, that kind of stuff for March 31st, don't think this is going to happen. Okay. I think all events like this have been canceled. I don't know about this one for sure, but most of the other school events have been, and that was to be here on this campus in the Millsap building. So unless you hear that that's still open, I would assume it's going to be closed. Okay. What else? All right. So I think that gets us down to where are we, what are we going to do, and how are we going to do it. I'm not supposed to be here today. I was told not to come. However, I had all my books and everything else here, so I had to be here to pick up that. I thought, well, since I'm here, let's go on and wind up things as well as I can with all my classes. Okay, I guess you've heard, starting either tomorrow or Wednesday, everything is online until April 6th, 8th, or something like that. Is that right? What's that?
It's April 3rd.
3rd? Okay, in my last class, one of the students said 6th or 8th. I couldn't remember.
I think that's still subject to change.
It's very subject to change. If they think that this thing is going to go away by April the 3rd, they've got their head somewhere it should be. Okay, so, no way. I mean, my wife's an epidemiologist, infectious disease epidemiologist, and she's been tracking this stuff like crazy. And so far, you know, we got started much later than Italy, but once we had our first cases, the U.S. and Italy are tracking just like this. We are, and you know, a lot of other countries have tracked much better than Italy. Italy is one of the worst, and that's who we seem to be following the closest. We are not doing well with this. Now, since then, with sports taking charge of their things and saying canceling seasons, canceling whatever, schools canceling, universities, you know, since all this stuff is happening independent of the government, we may be able to level it off a little bit, okay? But right now, we're not. The last time I saw her compare the graphs, they were still going right along. There is no stopping this. There is at best slowing it, okay? Hong Kong and Singapore both aggressively jumped on it like crazy, and their curves are much lower. South Korea did a fantastic job of testing. Their curve is much lower. The key to that is, with trajectories like this, just about everybody's going to be getting sick at once. And our hospitals and other health providing services cannot handle that. They can handle this. They can't handle that. Okay. And that has led to so many problems in China, Italy, Iran, and other places. So to think that it's just going to go away by April whatever is wishful thinking at best. Now, that said for that, like I said, I was told not even to come to campus today because my age, but more my immune system. Coming close to being shot, I have immunity, and it's been doing really well for what I've got, but it's not going to be, I don't know. Anyway, so after today, I won't be back until the whole situation is a lot better shape than it is. So even if school comes back, I'm not certain that I'll be able to come back. So it maybe we'll be continuing this till the end of the term. And my guess, summer term. And there's a really good chance that, okay. Now this isn't the flu, obviously, but it is a virus, and there's some people that are hoping that when summer gets here, just like flu season dies off, that so will this. However, Australia has had it, and Australia is in their summertime. So I don't think there's a lot of grounds for hope for that way, but there may be some. But it is a virus like the flu, and I don't think I was back here to remember this, but I've heard about it. In 1918, the Spanish flu outbreak, one of the deadliest of all time, it happened in the winter. It died back in the summertime because it was flu. But then in the fall, it came roaring back with a vengeance and killed many, many million more people. Okay, hopefully that will not happen, but there is a distinct possibility it could. So it may be, well, fall term was supposed to have been my last term here teaching. I'm retiring in February of next year. So it could be, this may be my last day in the classroom. I don't think so, but it could be, if it comes back in the fall really, really badly. Now, positive notes, they'll probably come out with a good antiviral sometime this summer. My wife is hopeful for that. There's several labs that are working on this. UAB actually has at least one or more immunologists who are working on vaccine. Vaccine work is going on. Vaccines will not be here within a year. Okay, they just cannot do it. There's just too many steps and too much protocol you have to go through to make sure it's effective and safe. And they've got to make sure both of those before they do it. And right now they're working on the flu vaccine for next year. Okay, it takes a year. They have to guess what flu viruses are going around and may be likely for next year. They look at what's happening in the South, where it's in the wintertime, in our summer. So they look at what they're making guesses on it. Okay, so there's no way there'll be a vaccine before next year. They are working on antiviral drugs for it, and there is a good hope that some of those will be discovered by summer, and that way people will have less severe cases of it. And once you do that, then the transmission rate goes down. They hope, So we'll see. That's all yet to be determined. So for right now, I'm planning not to be here the rest of the time. If I can get back, I'll be back. But I've been told not to. Okay, so we'll see what happens with that. So here's what my current plans are. Jonah this morning said he had used it in a computer science class. Have y'all had any experience with Zoom? Okay, Zoom is a package. My wife, professional meetings and things like this that they have that they don't want everybody travel long distances and go to. Small things, like research teams that are scattered all over the country or all over the world, get together and have meetings. They use a package called Zoom, and she says it's really good. I talked with the dean last night. She called and said, don't come to campus tomorrow. I said, I've got to. I've got to get my books and stuff. She said, oh, okay, yeah, that's right. You would have to get those. So we got to talking later, and I said, well, Karen said something about Zoom. That's what I'm planning to use my thing. She said, I've heard of that. That probably will work. I said, but I was wondering about the thing in Blackboard. I can't remember its name now. Collaborator. And she said, oh, yeah, that's better than Zoom. I said, oh, okay, well, then I won't look any further into Zoom. When I'm on campus tomorrow, I'll find out about Blackboard Collaborator. Now, if any of you use that, what did you think of it?
Well, we did it for one of my English classes, the teacher on the field, and it didn't work very well.
Yeah.
We eventually ended up switching to discussion.
Right. Was that Dr. Swanberg? Okay. She came in this morning to sort of fuss at me for being on campus because she knew my situation. I said, well, I had to come get my books and stuff. She gave me her phone number and sprayed the piece of paper with her Lysol or whatever, before she'd hand it to me. She's pretty serious about it. So I asked her, she said, oh yeah, I've used Blackboard and Collaborator. Don't use Collaborator. Zoom. I've used Zoom and use Zoom. It's reliable. It'll do it. She said, I can't speak for Blackboard Collaborator. She could say anything good for Blackboard Collaborator. So I'm going with Zoom. So by Wednesday, what my plans are is Wednesday by, 12:15, 12:25, something like that. I will hope to have you a code out there. I'm going to put it on Blackboard. Now, here's another thing. This new Blackboard, you can do an announcement and you can have it send out emails. The old Blackboard did this and did it really, really well. The new Blackboard, all I've heard from people is some students get the announcement, some don't. Some get the emails, some don't. I don't know what's going on. So I mentioned that to Dr. Swanberg this morning. I said, was it any better than, she said, send it to the students. I said, the only way I have to email students is through Blackboard. And I've heard it doesn't work well. He said it doesn't, but don't put a date on it. Don't put a start date or a time frame on it. Leave that blank, and it does better. She said if you do that, it screws it up. And that doesn't make any sense at all, but that's what our Blackboard package is like. So anyway, I will try to put on Blackboard, and the reason I'm saying it's going to be 5 till, 12:25 is I only have right now with Zoom, the free version is only good for 40 minutes, but you can do multiple 40s. That's what I've heard. Okay? Now, but that means after the 40 minutes is over, it dies. It ends, and then I have to do it again. Now, if I can get the paid version, this is what I got from Jonah this morning, so you know it has to be true. So, see, he had a computer science instructor that did this. She must have had actually, it was several in the class had the experience. She must have had the paid version because she could use the same number. The students, if you haven't paid for it, you're limited to 40 minutes. But you can use the same code and log back in and do another 40. And since this class is an hour and 40 minutes, we're going to have to probably do 3 40-minute segments, so the classroom won't last 40. So anyway, that's what the plans are. So look for and it'll be out there after 12:25, but it probably won't be much before 12:25 because otherwise I'm losing my 40-minute limit. Okay. So anyway, that's what we'll plan to do. I'll call roll through who signs on. I'll see flashing up when you're enrolled. Your phones or your computers, either one, should be able to do it. Okay? Now, I don't know if you need anything loaded on it, but they say it's pretty simple, and y'all are way more tech savvy than I am. So So I'm sure y'all can figure it out, can't you? Please say yes. Okay. All right. So we'll plan for that on Wednesday. Now, if I screw it up and can't get it, I'll send you a text saying, hey, I'm not ready yet. I can't do it. I can't get it to work, whatever. And this whole computer, this is what she had trouble loading Word Perfect on, so it may be it'll have trouble with that. So we'll see. But that's what let's plan to do. So every Monday and Wednesday afternoon at 2:25, I'll try to load it. Now, if I can get the paid version, then the same code will be good. You just, when it goes out, then you log back in and come back on for another 40 minutes. If I can't get the paid version, then I'm out too. Then I have to get a new code and then type that in, send it out. You have to get the new code to do it. So we'll waste a little bit of time there. So I'm going to see what I can do to get the paid version. I don't know how much it is. Y'all don't have a clue. Supposedly it works and works well, so we'll try to go with that. Does that sound okay? Hopefully people listening at home will hear this and know to do the same. If you know any or see any of the other students or communicate with them at all, get the word out. I will be, here's my hope and my plan, is once I learn how to do it, I will do a class in it and send it to every class that I teach. So it won't be listed as a MTH, I don't necessarily MTH227 class. It'll just be Zoom or something like that, but it'll be on your playlist. Okay, I'll put it on everybody's playlist, so everyone will be starting from the same place. That's the best I can come up with. Anyone have any better suggestions, ideas that you think may work? Okay, I'm going to give you your second test today. I forgot to pick it up. I meant to pick it up when I forgot my computer. I was in such a rush, I went right past it. So at the end of the class today, I'll go get your second test. Took it to the copy room to be copied. Yes?
Are you going to be able to pay the money out of those tomorrow?
I don't know. I hope so, but I can't guarantee that. Now, here's what I heard more recently, okay, that actually technically Tuesday, Thursday classes were canceled, not just moved to online, canceled. Supposedly that's to give us a day to get our acts together. Now, if I can get it going, then I'll go on. So try to log on about 5 till, see if there's a message out there. And that may be a dry run, a learning curve, type thing. I'd like to do that tomorrow. I'd like to do it for my 8:30 class, whether I can or not, I'm not sure. Then I've got a 10 o'clock class, I'd like to do that. And yours is 11:30, right? So, but I really need to do it for my 1:15 class because they have already lost one class when I was at meetings in Tuscaloosa, and it's a mini-term class. We got to have class. And so I'm going to try to be ready for that. So check and see. All right. Any other?
What about next week?
Next week is spring break.
So we won't be doing anything online?
No. Now, last week, our headquarters down in Montgomery, the two-year college system program down there, the chancellor came out with a thing and it was interpreted and stuff. I've only glanced at the thing, but I've heard people talk about it. If you think this sounds ludicrous, we think so too. But here's what it said. Any employee who goes out of state, okay, all official out-of-state travel was canceled, forbidden. If you voluntarily go out of state, you must then self-quarantine for 14 days when you get back. And wait, spring break, we can't go out of state. Well, that was, of course, because Alabama, a pristine state that we are, had 0 cases. And all around us, every other state had cases. So, What's that?
So we didn't have any tests.
No, we had tested at that point no more, or right around 50 tests. 50 people was all in the whole state of Alabama. And they probably didn't have results back from all of them. And then, of course, Friday, oh, here's a case, there's a case, there's a case, there's a case, you know, and ever since then it's just been going like that. So even though we may still have fewer cases in these surrounding states, it's still the same reason. We just now started testing. So whether that's still in play or not, my family has a farm over in Georgia, and we have a little 2-bedroom bungalow on our portion of the farm. It was split up among the 4 kids when our parents both died. So we built a little 2-bedroom bungalow so we'd have someplace to go with that. Well, that is 8 miles from the closest flashing light, 10 miles from the closest stoplight. It's out in the boonies. And I won't be around a single soul there at all. And so that's where I'd rather be. I told my boss out on Friday before I knew any of this other stuff. He said, go to the farm. He said, I won't know it. You know, you're going to be, if you feel like you're safer there than in Birmingham, go to the farm. And he said, don't worry. Well, if I'm going to be teaching from home, guess what? I'm self-quarantined. So I will. I don't know. We haven't decided yet whether we're going or not. But that other thing is completely obsolete now. Whether they rescind it or not, I don't know, but it's completely obsolete because the whole reason that we don't have it in Alabama was ridiculous to begin with. So anyway, but students can go out of state, then they bring it back and infect also as instructors. Fine, no problem with that, folks, you know, but we could. But as it is now, I'll be effectively quarantined at home anyway. Whatever that means, self-quarantine. I'm not going to go anywhere that I don't have to go, you know. Our church canceled yesterday. Oh, it didn't cancel. They streamed it, and they encouraged people not to come. In Sunday school classes, they encouraged not to meet unless you worked out something. We tried to get the Zoom thing going then, but we didn't have time to do that for that. So anyway, I'll be effectively quarantined anyway. So I may go to the farm, I may not, but it's not going to matter. But then I guess April, if it is April the 3rd, you thought, I might not be through my self-quarantine then. But again, I think that's not relevant anyway at that point.
Some also said it's going to take at least 8 weeks.
Oh, yes, it is. I mean, hey, again, us in Italy, you know, it's going to be way longer than that. If you want my opinion, summer is probably going to be online as well. I see no way that we're going to be past even the worst of it by then. Okay? I think it'll still be getting worse. Now, if we do level off, maybe we'll be past the hump, but it'll still be all over the place.
Do you know what's going to happen for like graduation and honors awards day and stuff?
Okay. I was hoping this morning to have time to find out about Honors and Awards Day. I don't think it's going to happen. That may be why they moved it to the 3rd in order to try to get that in. But I frankly don't think it's going to happen. Now, I am still going to try to get in touch with someone in the business office and make sure that you can still receive the award. But I don't know. I had hoped to know before class today, but I have had students showing up out of the woodwork trying to get things done now that school's not going to be happening. And in fact, I didn't even get to finish eating lunch because a student came in who couldn't take her test today but could take it tomorrow. Well, I'm not going to be on campus tomorrow, you know, and so it was all sorts of weeping and gnashing of teeth. You know, so
You don't know about graduation?
I don't know. For certain, I don't know. But my guess, I don't see how it could happen. But that's my guess. And that and 50 cents won't buy you a cup of coffee. So, anyway.
So I guess we just send you a picture of the test on email.
Picture of what?
Oh,
Okay, testing. Since y'all are all take-home test anyway, I will just send it probably as an attachment to an email, and it will probably be PDF format. I'll have to check. If I have it in Word, I'll send it to you in Word. But actually, more likely, since that's why. It's one of the reasons I use. Another reason I use WordPerfect is that if my electronic copy gets out there, most people can't read it anyway. But the if I only have it in Word, then WordPerfect, then I'll have to do it as a PDF and send it to you that way. Because Karen said, hey, you don't want people being able to change your stuff. So don't people have writable PDFs? She said, oh yeah, that's right. I guess they could if they really worked at it and change things. So they do grants, all sorts of things like this, sending a PDF. So that's probably what I'll do. It'll be easier. We have a scanner at home. We haven't had it out and operating in I don't know how long. But Karen said, look, I can scan on my phone. She has a fairly new phone. Boy, it does a great job. So if nothing else, I'll scan on the phone. So, yeah, that's what we'll be doing. I'll give you.
And what about the submitting tests?
Okay, then you'll have to send it back to me PDF. Yeah. And I think my computer will take other things. My old desktop would not accept the JPEG file, so a picture was not a good idea. But I think this one will accept the JPEG, but I know it'll accept the PDF. So that would be the best thing. Good questions. And in the Zoom thing, you'll be able to communicate. Now, I don't know, probably only one person at a time can be speaking and pick up. But I think Karen said you can have up to 100 on it. And I don't have any classes more than 30, so I think it won't be any problem. But if I see pictures, the pictures could get very small, but in this class, it won't be an issue. Okay, so in my bigger classes, it might be a little more. I don't know how it's going to work. We're just going to have to see. But, yeah. And when it's time for the test, that's why I'm taking everything home. And if I have to make up a new test, I can. But all that's electronic anyway, so I wouldn't have to take my books home except just to refer to them. Which section did we cover again? Okay. All right, any other questions? Good questions. Okay. Where we left off last time was Chapter 12, Vector Value Functions, and 12.5, Arc Length and Curvature, and we had just defined curvature, and we're getting ready to do Example 4, which is showing that the curvature of a circle of radius r is indeed, like they told us it was, 1 over r. Now, this book uses a capital K for curvature. Other texts I've taught from, and you may see this, it's the only reason I'm saying it, typically use a capital K for curvature, a capital kappa for curvature, which looks very much like a K, but this is a K, it's not a kappa, okay? So you may see another symbol that looks like a K, that's a kappa, Greek capital letter K, kappa. And that's what most other texts use. I'll use K's, they're easier to draw. Okay. So, now, as they say here, without loss of generality, you can consider the circle to be centered at the origin. No problem there. And then your equation would be x squared plus y squared is equal to what? R squared. Perfect. Okay? Now, what is your, I keep wanting to say kappa, but curvature. Now they give us this formula here. And I hate to go back. They haven't given us the new formula yet, so we almost have to maintain this one, okay? There is a much easier way to do this, but we'll do it this way. This is the Cartesian form of a circle. This is not going to be easy since we don't have our other form for curvature, so I shouldn't have written this one down. What we do have is this. Here is the polar form. R squared is equal to, well, let me see. Let me correct that. R is equal to, I could do R squared, but easier to do R. R is equal to, and it doesn't really matter how you do it. Now this is vector R. This is position vector as a function of theta. Is equal to the magnitude of R. That's not, it's the same R but just the magnitude, but they put it as a italicized R. Cosine, and you can put in, we'll just leave it. I was going to put it omega t, but you don't need the omega t. I plus R, not, it's just a scalar R, sine theta j. X coordinate is R cosine theta, Y coordinate is R sine theta. Very standard. This is of a circle of radius R. Okay? And if you'll square this, you'll see that you come out x squared plus y squared. I mean, it comes out exactly that. Because this is indeed xi plus yj. Okay? And x squared plus y squared equals r squared. So it's really doing the same thing, but this puts it in terms of a unit circle type sense, okay? R cosine theta. It's not a unit circle, it's R the circle, okay? Now, if you're getting it in terms of the arc length parameter S, which is, if you look at the thing here, this is the only definition we have so far for curvature, okay? So we needed an arc length parameter, okay? So that's why we're having to do this. So we know that S is equal to R theta, right? Okay? Now, so if we want this in terms of S, let's do that R is equal to S divided by theta. Well, that's not what we want. We don't want the theta. We want theta is equal, let's change that around. You would think it would be that way, but we won't. Theta is equal to S over R. Okay? So, seems like a weird way to do it, but that's exactly how they do it. So now, your R of theta, which was now going to be R of S, but I'm still going to put the theta in here. No, I won't. I'll put it S over R. R is a function of S over R is equal to R times the cosine of S over R, I, plus R sine S over R, J. Okay? Rather bizarre, but true. Okay, and these R's are the same, okay, magnitudes. Okay, now, again, remembering we want to do our unit tangent vector as a function of S. That's how we're going to get our curvature. Well, how do we get unit tangent vector. What's the first step? Of the r, yeah. So r prime. Now, they are taking away the over r and just doing r prime as a function of s. So we will too, because we'll just do it as a function of s, okay? Because r is fixed, so that's just a constant there. So this will be r. What's the derivative of this? Negative sine s over r I with one other little thing. Because this is with respect to s. Remember? That's what this is derivative is. That's our independent variable. So what's your chain rule tell you? You did the derivative of the outer function, cosine function. Now do the derivative with respect to x of the, excuse me, of the inner function. I knew I needed to sneeze and bring Fred in. Came to my rescue thinking I must be dying in here. I hate to go through it all again. How much do you know of what's happening? Yeah, we're going online, and what I'm going to try to do, have you ever used a package called Zoom? You have. What did you think of it? Right. Yeah. That's what we'll be using. Now, I don't know now if I'll have the free version, which is limited to 40 minutes, or a paid version, which I can use unlimited. But if you are the student, if you have the free version, yours will go up in 40 minutes. If I have the paid thing, the code I give you at the beginning for the call will be good, and when your 40 minutes are up, you just re-enter the code and come in again. I can tell you're doing that because I'll see your picture go out, and then I'll see it come back up. So that's what I plan to use. Now, my wife and I talked about it yesterday, and that's what we had decided. Then the dean called last night and said, no, Blackboard Collaborative is better. So I quit researching Zoom, and then got here this morning, talked with Dr. Swanberg. She said, no, don't go with Blackboard Collaborative. It's not better. Those go with Zoom. So now I'm back on Zoom, but I don't have enough information about it, except what students like you have said. So we will, I'll try that. So I'll be starting around, I'll shoot for 12:25 every day, so I can get the code, get it up. If you're limited to 40 minutes, then I want to start right at 12:30, so we don't have any lost time at the beginning. Whether I make that or not, I don't know. Don't hang up on me if I'm not there at 12:30, but I'll try to be 12:30 Monday and Wednesday, and we'll just have classes as normal. Now, whether I can do Screencast-O-Matic, I haven't figured that out yet. If I can, I will, so it'll be out there for other people as well. If not, I'll leave the classes out there that are in YouTube videos from previous terms, and they'll still be there, but all we'll have is the Zoom. And I don't know if that's saved or not. Does anyone? Is that a file you can save and go back and see later? I'm hoping for people who are not here say that they can, but if not, hopefully I can still do Screencast-O-Matic and save them that way. We'll see. I just don't know if you can YouTube and Zoom at the same time. Uncharted waters for me anyway, so we'll figure it out as we go. So every Monday and Wednesday at 12:30, I'll try to get started, get the code by 12:25. As close to that as I can, and go from there. I don't know what kind of delays or downtime, or I don't know any of that. We'll just have to play it by ear as we go. Now, the official word is either we will be back or they'll make another decision, either by, Dawson heard April the 3rd, student in my first class said either April 6th or 8th, I don't remember which he said. The odds of me being back either of those 2 days is pretty slim. Because the dean called me at home last night and said, don't come in tomorrow. I said, I've got to go in tomorrow because I have all my books, all my materials, everything is in the office, it's not at home. Except just what I was grading in my grade book and stuff. She said, oh yeah, that's right, you will need those. I said, yeah. So I said, I'll try to work everything out that I can tomorrow. So far I've had WordPerfect put on this computer because I only had it on my desktop. Most of my tests are in WordPerfect. So in order to access my own test, I needed WordPerfect on here. I just got that done right before class, so that's why I'm still here. I'll be here for my differential equation class, I think, too. Just since I'm here this long, I'll go on and meet with them. That's 2 students. Sometimes they're both not here, so we can social distance okay that way. And I told my wife, I said, all my classes are small today, will be far apart. What I didn't anticipate was everybody in the world coming in my office today, but it's okay. So anyway, I doubt if I'll be back, even if the school is back because of my health condition and my immune system and my age. It's probably not going to be a good idea for me to come back on campus. So I'll probably just do online, I'm guessing, for the rest of this term. And if you ask my guess, summer as well. That's just my guess, because my guess is we're not even going to be at the peak summer, or we're going to be right in the middle of the peak, and that's going to be probably one of the worst times to come back. But I don't know. I don't have a crystal ball or anything else. My fear, it could be this disease may actually die back a little in the summer and then come roaring back in the fall. So we could be, as I said before, this could be my last day teaching from this classroom, you know. I may be online the rest of the time. If I'm upright the rest of the time, I really won't go there. But anyway, so that's where we are. Now, weren't quite finished with this problem. We were trying to take the derivative of this displacement function written in terms of your arc length parameter, but we didn't quite have that first term differentiated yet. We differentiated the outer function, cosine differentiates to minus sine of s over r, but we still have the chain rule to go. Taking the derivative with respect to s. That's why I came back and rewrote it this way.
Divide by r.
Yes, yeah, over r. You're absolutely right. So 1 over r, and there goes your r's. Okay? Let's do the second term. What would that be? Second, cosine s over r j. I can do that part. And the r's cancel again. So there we have our derivative, dr ds, as a function of arc length parameter of this. Now, what's the next step? Yes, we divide this by its magnitude. What is the magnitude of this? I'm going back to r prime because it's easy to write. R prime of s is 1. So that means this thing, since its magnitude is 1, that is its own unit tangent vector. Because r of s divided by its magnitude is the unit tangent vector. So this is also the unit tangent vector of s. Okay? Well, that doesn't quite get us there, but it gets us close. Because here's our definition. So what do we need to do with it?
So we need to
take a derivative again. So this will be this prime will be cosine S over R I minus 1 over R sine S over R, I can't write, J. And then the last thing we have to do is do the magnitude of that. Okay, so let's do that. The magnitude of, now I'm not going to put a unit vector then just to keep it from being confusing, because it's no longer a unit vector necessarily. So I don't want you to think it is, so I'll put an arrow over it. Okay, and what would be the magnitude of that? Okay, is it that 1 over R squared times cosine squared, right? S over R plus 1 over R squared sine squared S over R. Okay, squared, yes, sine squared. Okay, I can factor out the 1 over R squared, and what's left? 1. Okay, and what's the square root of 1 over R squared? 1 over R. That shows that indeed your curvature, which is, that's your curvature, is 1 over R. We've just shown it for any general circle, any circle, 1 over the radius. Okay? That's how we did it, sort of sloppily, but did it. Let's do this from, let's see how they did it. Without loss of generality, you can consider the circle to be centered at the origin. Okay? That makes it a lot easier. Let xy be any point on the circle, s be the length of the arc from R0 to xy. In that picture right there. Okay? That's your S. Okay? Now, by letting theta be the central angle of that circle, right there, you can represent the circle by R as a function of theta is, this is x of t I plus y of t j, right? With x of t is r cosine of theta, and the y of t is r sine of theta. So there's your x of ti, y of tj, r cosine I theta plus r sine theta j, r cosine theta I plus r sine theta j. Now, that's a function of r. We want it as s being the, used in the formula for the length of a circle, the arc, circle arc. This is an arc s. The length of the circle s is equal to r theta. You can rewrite r of theta in terms of the arc length parameter as r of s, and everywhere you saw a theta up here, put it as theta is equal to s over r. And that's what they did. R times cosine s over ri. Same thing we did, r sine s over rj. Okay, then you take the derivative of that, and you get minus, and again, your r that's in front gets wiped out by the chain rule 1 over r later, so this just becomes minus sine s over ri plus cosine s over rj. R prime, you take its magnitude, this squared plus that squared is equal to 1. Okay, so that implies this is indeed your t. These are indeed exactly the same. So R prime of T divided by R magnitude of R prime of S, is exactly R prime of S. And that would be exactly the same function here, okay? Which you then turn around and do the magnitude, okay. Skip so many steps. First do the derivative of that, and that just introduces a 1 over R here and a minus 1 over R there. They skip that step, and then you want the magnitude of that, and they skip those steps, and that's 1 over R. And that's true at every point on the circle. Any xy value you choose, that would be it. Okay. Now, Theorem 12.8. Okay. Well, there is something at the bottom of page 858 may be worth looking at. Because a straight line does not curve, you would expect its curvature to be 0. Would I expect that? Yeah. The radius would be infinite, and the curvature is 0. It said, try checking this and finding the radius of curvature for the line given by, and they have a line here. Do you want to do that? They didn't do anything with it. They just said you could do it. Is that something you want to see done? Are you okay with it? This is what's on the bottom of page 858. Just about 2 lines of type and 1 equation, and they just leave it hanging right there. Do you need to see that or not? Up to you. Yeah or no? No. Okay. Then we'll go on to this. Yes? I'm sorry? This is 12.5. Okay? This is the last section of chapter 12. I do have your test ready today, so don't leave class without it. Okay? All right. Now, in the last example, the curvature was found by applying the definition directly. That requires that the curve be written in terms of the arc length parameter S. Okay? That was not a bad thing on a circle because of that relationship. S is defined as a relationship between R and theta on a circle. Most functions, it's not nearly that pretty and neat and clean and tidy. Okay? This requires it to be written in terms of the arc length parameter S. The next theorem gives 2 other formulas for finding curvature, and it says the proof is left as an exercise. So here is that theorem. If C is a smooth curve given by R of T, remember what smooth means? No gaps and no points. Okay, smooth curve, meaning it has a first derivative everywhere on that curve. Smooth curve given by R of T, then the curvature K of that curve C at any time T. Now our parameter is T. Generic general T. Okay? It doesn't have to be S. To get that arc length parameter in terms of that is sometimes a really big pain in the neck or some other body part. Okay? So here's the formula for it. Remember before it was just the magnitude of T prime of T. Of T prime. Okay? That was what it was earlier. What changes now is you divide that by the magnitude of R prime of T. Okay? Now, let's just go back and remind ourselves. Well, yeah, there it is. It's the magnitude. The curvature was this before, but that's S. Okay. Now, if we went far enough back, I don't know. Okay. The SDT is magnitude of R prime of T. Okay. Let's just not even mess with that. Let's just go back to here. All right. Yep. I'll get there in a minute. There it is. Okay. So the kappa, I'm sorry, I can't call it kappa. Curvature is, before was T prime of S, but if you have T in there, it's T prime of T divided by R prime of T. That's about the simplest form I've seen this in. Other books really make it a lot more complicated, but even that is a hard thing to get. Because remember, what you have to do is take this first, R prime, divide it by R prime magnitude, then that gives you T, then you take the derivative of that, yeah, it's a mess. So here's something that's a lot easier. You know your R. Hopefully they give you your R. So take its derivative and second derivative. Do the cross product of those two, magnitude of that, and divide it by the R prime that you already got, magnitude of that cubed. Okay. It's a lot easier than doing this, but it's still fairly involved. Because R prime of T is ds dt. That's what I was looking at before, and here's on the slide. The first formula implies that the curvature is the ratio of the rate of change of the unit tangent vector, written as a function of T, to the rate of change of the arc length. This is the rate of change of arc length. Okay? To see that this is reasonable, let delta T be a small number, then the T prime over ds dt what we're missing is absolute values there. These absolute values are taken care of, but that is not. And that is T of unit tangent vector T of unit tangent vector T as a function of T plus delta T minus unit tangent vector as a function of T alone divided by delta T over, and here's S of T plus delta T minus S of T divided by delta T. And you can wipe out your delta T's here, and that gives you change of unit tangent vector for change of S. Okay? Which is pretty close to what we were calling kappa before. Not quite the same, but pretty close to it. Okay? In other words, okay, for a given delta S, the greater the length of delta T, the more the curve bends at T, and that's shown here. Here, it's not a lot of bend. So you change your T of T here, which is tangential here, and your T of T plus delta T, which is tangential there. Well, if you take this, subtract it from this, here's your change of T, delta T. And that's a little bit of a thing, but not a huge amount. We'll do the same thing over here. Here's your T of T here. Here's your T of T down here. Look at the change between these two, this delta T here. Way more than either one of those, okay? So yeah, the greater the curvature, the larger the delta T, okay? Thought we had already landed on that, okay, but they just wanted to show us again, I guess. Okay, so here's example 5. Find the curvature of the function given in terms of T. Now, does anyone want to go and try to figure out what the S, this will be in terms of arc length parameter S? Please say no. We don't want to do that, okay? So what do we do first? Take a derivative, why not? R prime of T. And what would that be? Help me, somebody. Say 2I 2TJ minus T squared K. Okay. Now, from our formula, we need an R double prime as well. So let's do that. R double prime of T is equal to really? Derivative, yeah, that's a 0, okay? Two J, or not 2J, that's the question. Okay, second, minus 2TK. All right. And what do we do with that? Whoops. Take a cross product of those two. Okay? So what is R prime of T cross R double prime of T? And remember, cross products need to be in that order. So keep the order right. How do you do that? IJK across the top, followed by an IJ. Just repeating yourself, aren't you? Okay. And what goes next? Two. Second. It's 2T, isn't it? Yeah or nay? Yeah. Okay. Minus T squared. 2 and 2T. Okay. Next. 0, 2, negative 2T, 0, 2. And by the way, if it looks like it sure is, you take the derivative of that, derivative of that, derivative of that. That's exactly what you're doing. But, all right, how do we proceed from here? Help me. Negative 4T squared I, 0, plus 4K. Okay, now let's do our up diagonals. 0, plus 2T squared I, plus 4TJ. I didn't leave any room for the J term, so I'll have to squeeze it in. So this product here is a vector. You have to combine like terms here. This will be a minus 2T squared I plus 4TJ plus 4. Oh, I forgot to do. No, I did. Yeah, we got it. Plus 4K. Okay, now what do we do with that? Yes, you have the magnitude of that. Okay, here it is up here. So R prime, I'm going to shorten it a little bit. R prime cross R double prime. Magnitude is what? Help me out here. Don't leave me hanging here, huh? What's the magnitude of that thing? Okay, don't you square that? Yeah, so that would be 4t to the fourth plus, got it, plus 16. Okay? Now, what our hope is could that possibly be a perfect square trinomial in there? If it is, then we can remove the radical, right? So the question is it? Well, one thing we can do to make it simpler is, of course, what? 4, and that's under the radical, so if you get out the radical, that's factoring out a 2, right? Times the square root of, and when you factor the 4 out of this, what did that give you? T to the fourth. All right. Okay. Now, I ask again, could that possibly be a perfect square trinomial? Anybody? And what would it be? T squared plus 2. Plus 2. Oh, okay. Squared, right? Okay. If you square this thing, square the first term, t to the fourth, twice the product of the 2 plus 4t squared, square the last 2 things. Side. Squared it and then took the square root and I lost the square. Okay? Agreed? So there's our numerator. What's our denominator?
Take the magnitude of first and cube.
Cubed. Ugh. Sounds pretty bad, but let's do it. What's the magnitude of r prime? Anyone want to do that for me? It's not that bad. Four plus 4t squared plus, let's say again, t to the fourth. Hey, what is that? That's exactly what we had down here, only in reverse order, but that doesn't matter. So sure. Okay. So this will be, the square root of that would then be t squared plus 2. But remember that was cubed, right? Okay. So this one will wipe 2 of those out. 1 of those out, leaving us 2. Okay. So that gives, where am I? The k, I keep wanting to call it k, kappa. K, the curvature, is equal to 2 over t squared plus 2 squared. Okay? Now, did they say at any particular place? They didn't. Now, I don't know why they did this. They said it's not apparent whether this parameter represents arc length, so you could use the formula of that, and I don't see why you would want to use the formula of that, but they said you could, and so you certainly could, and find the r prime of t, which we found to be t squared plus 2, exactly what we found, and then divide your other thing by that, and then take the derivative of that, and then carry it through there, and there, and there, and that looks like an awful mess, and ultimately get 2 over t squared plus 2 squared, which is exactly what we got. I think our way was much easier, okay? You didn't have nearly as many really messy derivatives to take, nor did you have as many absolute or magnitudes to take, and they weren't nearly as difficult to do. So I think we're okay there. All right, let's watch how they did. I'm sorry, I forgot this has it. Any questions before I erase my scratch? They did it what I consider the hard way. We did it what I consider the easy way. Not apparent. Okay, I've already said that. Whether that parameter represents arc length, which I would say no, it doesn't. So you should use the formula, that one, which is r prime of t being that, exactly like what we found, and the magnitude being that, which is exactly what we found. And the t is r prime over magnitude of r prime, which is that deal. And then you've got to take a derivative of that, and that's what you get, okay? That's a quotient rule. And that's the low, t squared plus 2, d high, and d high was 2 minus 2t, 2j minus 2tk, minus high, I've already gotten lost where I am now. Yeah. The high, you just have to write down the whole vector. D low would be times 2t, and that's what they did, minus 2t times that initial vector, the vector we had, over low low, which is t squared plus 2 squared. And then you combine your I terms, and your only I term came from here, minus 2t times 2i, which is minus 4ti, and your j term is why this is a harder way to go. 2t squared plus 4, those are all j's, minus 4t squared, that's a j, so that would be your minus 2t squared plus 4j. That's where they got that one. And then the k term is minus 2t cubed minus 2, not minus 4t, k, minus another t squared, so, oh no, this is a plus 2t cubed k, and this has been a minus 2t cubed k, so those disappear, and you're left with just a minus 4t k. So that's where that one came from. Right. That's your t prime of t. Now what you have to do is do a magnitude of that. And still divide it by your magnitude of r prime. Isn't this fun? That is your 16t squared. Now you have to square this entire thing here, which is 16 minus 16t squared plus 4t to the fourth. Okay, that's that part. And then you got another plus 16t squared from there. This one and this one cancel out. And that leaves you 4t to the fourth plus 16t. Okay. right back along what we had before, only it took us a lot less effort to get there. And they could factor out the 4. That gave us a 2 on the outside. And that would leave us a t squared plus 2 on the inside over t squared plus 2 squared. So that's a 2 over t squared plus 2. That's the magnitude of your t prime, length of t prime. Then you have to divide it by the magnitude of r prime. And you have to go way back here to see the magnitude of r prime. That's it, t squared plus 2. So that gave you that squared in the denominator. What a pain, okay? Now that leads to, we're not, oh yeah, top of page 860, okay? Curvature and rectangular coordinates. Don't you like all these curvature formulas? Okay, we have it in arc length parameter, we had it in your regular parameter t, now it is in rectangular coordinates. And c is the graph of a twice differentiable function given by y is equal to f of x, and the curvature k, okay, now, note what's going on here. C is now a graph of a function that's y is equal to f of x. You're in the plane now. You're not out here in space anymore. Okay, that's why things look a little simpler. You're strictly in the plane. Y is equal to f of x. And the curvature k at the point xy is then y double prime, absolute value of y double prime, divided by 1 plus y prime squared to the 3 has power. Now, do not fret this thing. That's the period that's at the end of this sentence. It's not a prime, it's not anything, it's a period that's at the end of this sentence. It's just very poorly placed, okay? When I first looked at it, I said, what in the world is that symbol there? It's just the period that ends that sentence, okay? So don't sweat that. Okay. Any questions on that? Yeah.
Is that y double prime?
Y double prime, magnitude of y double prime. See, these are all scalar functions now. That's a scalar function. Differentiable scalar function. So now you don't need magnitude, you just need the you don't need magnitude, you need the absolute value of the y double prime at any value x that you have. And this is the y prime squared, 1 plus y prime squared, is right to 3. The square root of the cube of that, or the cube of the square root of that, whichever you want to do. Okay. Now, that kind of leads to something else. Let C be one of these curves with some curvature K at some point P. The circle passing through that point P on that curve C with radius R is equal to 1 over K. That means that is a circle now, okay? It's called the circle of curvature when the circle lies on the concave side of that curve and shares a common tangent line with the curve at that time, at that point P. A lot of blah, blah, blahs in there. The radius is called the radius of curvature at P, and the center of that circle is called the center of curvature from that point P. Okay? So it's called the circle of curvature with the radius being radius of curvature, and the center of the circle is the center of curvature. Here's sort of a picture of that. Okay? The circle of curvature gives you a nice way to estimate the curvature K at a point P on a curve graphically. Using a compass, you can sketch the circle that lies against the concave side of the curve. Sure, I think we all have our compasses, don't we? Did y'all ever have compasses in high school? I don't know if they even make them anymore. I'm sure someone must. You even know what I'm talking about, a compass.
I use
Oh, you did? Yeah. Okay. We're not talking about a north-south compass.
Yeah.
We're talking about the point at one end, a little pencil at the other, and then you draw your circle. Yeah. Okay. And you can do that. If you have a point here, pick your radius that most tightly fits the curve there. They really should one that fits really, really nicely here. And then that's your center of curvature where your point is. And that is your radius there. That curve K. If the circle has a radius R, then you can estimate the curvature to be K equal to 1 over R. Know that R, and you have a really good guess at what the curvature is. Okay. Here's example 6. Find the curvature. Yeah. I'm sorry? 3 minutes. My word, where did it go? We were having so much fun. So maybe we ought to stop here because I don't think we can get this one done in 3 minutes. Okay? Hopefully on Wednesday, this is where we'll pick up sometime around 12:30ish in the afternoon and go until sometime around, yeah.
Are you going to email us like codes and stuff?
Yeah, because I don't think I can get the code until I open the course, and when I open the course, the clock starts. So I'm going to do it right around 12:25. I'm shooting for between 12:25 and 12:30. Maybe after 12:30 if things don't work out, which you almost guarantee they won't work out the first time anyway, as well as you'd like. Okay? So I'll literally see you then. It's a virtual you, but I'll see you. Homework exercises here would include any of the odds. Now, concept checks up at the top, you can always look at those and think through those. But the exercises begin with number 3, any of the odds 3 through 7. They're all at Calc Chat. 9 should be at Calc Chat. Any of the odds 11 through 15 should be at Calc Chat. 13 is also at Calc View. 11 should be at Calc Chat. 19 and 21 are both at Calc Chat, with 21 being at Calc View. 23 to 27 are at Calc Chat. 29 through 35 should be at Calc Chat, with 33 being at Calc View. 37 and 39 should both be at Calc Chat. 41 through 47 should all be at Calc Chat. Well, let's see. If you want to hang off on that one for just a moment, we didn't do the example with that one. I think that's what example 6 is. So if you want to hold off on that one until we do example 6, you can. Or you can go on and try it because they didn't have one just doing that, but then definitely hold off from 49 to 53. That's where you'll find the curvature. All right, good deal. All right, this is going to be so bizarre. My wife's going to be working from home too, and she said, I don't know how I'm going to put up with you talking all the time because I'll be teaching most of the day, every day, like I normally do. So I may be outside teaching, I may be upstairs and she's downstairs. We'll somehow manage something. But I got to stay within range of our wireless system. Yeah.
So are you planning on, with Zoom?
Of what? Yeah.
With Zoom, you can screen share. So are you planning on screen sharing? Like you won't do a PowerPoint and then sharing your screen?
that what you're planning on doing?
Okay, I've never used Zoom, so when you say freeze it?
Or you can screen share. So say if you're doing.
Oh, screen,
So like
what are you saying? Are you saying freeze it or screen capture?
screen share.
Screen chat,
Screen share.
screen share.
Yeah. So basically, you know, if we're all logging in on our computers, and you can share your screen so that way our computers are showing what your computer is showing.
That's,
So if you're going through the PowerPoint, then you'll be able to see the PowerPoint on our screen.
yeah, that's what I'm hoping to do so you don't have to look at me. Okay, and that's the point of your question, wasn't it? So you wouldn't have to look at me. Right, yeah, I understand. Okay, yeah. I don't blame you. Okay, that is what I want to do. Now, I haven't done it. It sounds like you know how to do it. Okay. Well, I got another class coming up, so I don't know if we'll have time. How far do you live from Southside Birmingham? No, I think my wife will know how to do it. Hopefully we'll get it figured. Yeah, but I'm serious. How far do you live from Southside Birmingham?
I'm in home.
Homewood. You know where Forest Park is? You know where Avondale is? You don't?
I'm not doing
Oh.
right directions and stuff.
Okay, all those good restaurants that have just opened up in Avondale, you've not been over there? Ooh, man, you haven't lived. Okay. Okay, east of UAB, you know, University Boulevard goes through UAB. Are you familiar with that? Okay. If you continue east on University, at a place they call Lakeshore, you know where I'm talking about there? Oh, you do. Now, not Lakeshore Lakeview.
Oh,
Lakeview. You just keep going on University. You'll get to a golf course. Well, let's even past that. You know the golf course I'm talking about? Okay. If you go east on University, you get to an area that's called Lakeview. And at a stoplight there, University changes to become Claremont. You don't turn anything. It just was University, is now Claremont. Continue from there for about a couple or 3 miles. I doubt if it's 3 miles, maybe a couple of miles. You go under 280, okay? You know where St. Vincent's Hospital is? Ah, that's a better place to start. St. Vincent's is on Claremont, okay? That was University. So if you can get there, okay, yeah, of course you know that. That's where 280 comes from. So at Claremont there, if you get off there at University, no, it's still called University because that's the exit there. Yeah, okay, I'm sorry. That's still University. You go east on University, and then a very short time after you pass St. Vincent's, you'll come to the area they call Lakeview, and just continue on that, and that's Claremont. You go on into, you come to a golf course on the right, that's Claremont. You've got a couple of Y's that you have to make. You know, Claremont always stays to the left of both of those Y's. Before you get to the golf course, it's a Piggly Wiggly, and then you got golf, and that's on the left, golf course on the right, and then from there, it's under 2 miles is my house. And if I get in serious trouble, would that be a difficult thing for you to do? Okay. I think with my wife, I won't get into difficulty. Do you mind dogs? Okay, we have a golden retriever who's everybody's best friend. So she'll be all over you. You know, if she makes a noise that even sounds like a bark, it's excitement, and she'll go and pick up something, anything, a leaf, a stick, a toy, or anything, and she'll just go crazy talking with you for the first 15 minutes you're there. And my wife will kind of say, shut up, told me. Yeah, so anyway, so if you don't mind dogs, I hope not to be able to have to call you, but if I get in the Navy, we called it extremis, into a situation you can't get out of, I might give you a call. So you have actually operated that before. Do you have the paid version or you use the freebie?
Free.
Free, okay. I don't know which we'll have. I'm going to try to find that out before I leave today, if the school has Zoom or not. If they do, I might be able to get a paid version. That'll be easier on y'all and on me because I don't have to get a new code for every 40 minutes.
Well, when I used it, I used the free version.
Right.
And it didn't cut off for 40 minutes for me.
Oh, it didn't. So it's only if you have high usage probably that it would.
I'm not sure because I've done like through my job, I do like a presentation on Zoom.
Oh, okay.
So I have somebody go on Zoom, and then the presentation is usually like about an hour. So,
Wow.
And it just kind of cut off for me.
Okay.
But maybe it's if you have more people.
Yeah.
In the meeting.
Yeah. My wife said something about 40 minutes, but that may be because she was on on tele something another, and it's a.
What time does your other class start?
I have one. The next one right now. It start. What time is it now?
It's 2:17.
2:17. Yeah, it's 2:30. So we got.
I can show you like real quick.
Okay. Yeah, but I don't even have it yet. So yeah. Well, let me turn this off so I can be voting while you're holding that up. Well, let me do